Okay, so hi everybody, welcome to our molar mass of lab gas laboratory that we're going to be doing today. I'm going to go ahead and read the background. It says, in this experiment, you will determine the molecular weight of the gas butane. That's what we use in lab. You will, or I will, release the butane from a pocket lighter. This is going to be one of the things that we use, and allow it to displace a volume of water. From the volume of the butane, the weight of the butane, the temperature and pressure, you can easily calculate the molecular weight of butane using the ideal gas equation. So there is our ideal gas equation. Let's be as clear as we can about that. The molecular weight is actually included inside the PV equals nRT, specifically the moles, because if you remember that moles is actually equal to grams over molar mass. And what we're talking about determining is the experimental molar mass of butane. Okay, so we're going to be using the ideal gas law equation to do this. We're going to use a 250 milliliter Erlenmeyer flask, a lighter, a glass plate, a thermometer, a trough, and a graduated cylinder. So as we go through each of these parts, I will try to talk with you about what you should write down in your data. You are going to be recording data and including that at the end of this ed puzzle as your demonstration of attendance of class. Plus, you're going to need this data to be able to record it or to be able to use it for calculations. Where should you record this data? In addition to on the ed puzzle, well, you're going to need to write it down. You should also record this data here in the data sheet on your laboratory. So it's probably a good idea for you to have made a copy of this laboratory at this time so that you can have a place to record your data. Okay, so we are going to go ahead and get started. And the first thing we're going to do is fill a 250 milliliter flask with our water. And so here is my 250 milliliter flask, and I'm going to go ahead and fill it with water. There's 100 milliliters of water I'm pouring in right now. And then here is another 100 milliliters of water I'm pouring in right now. This is a 250 milliliter flask, so I know it's going to hold the 200. And then I'm going to go ahead and pour in another 100 milliliters, but I'm not going to be able to fit it all. So I'm going to tell you how much we actually got to fit in here. And I need to carefully add it all the way up so that it is close to the very top. And so that when I place, there we go, that is everything. In fact, I have added a total of 200 and let's see if I can do the math here. 200 and let's see here, 256 milliliters of water to my Erlenmeyer flask. The next step, it says, is to fill a trough with water. And so you might notice that here is my trough. It is actually filled with water. I am going to hold the glass plate over the top of my Erlenmeyer flask. That's what I'm doing right here. And I'm going to hold it tightly. And by the directions, it says to carefully turn the flask upside down and place it underneath the water. So that is what I have done. Taken out my glass plate there, and what I have right now is my 250 milliliter beaker, and it has no gas bubbles in the top of it. That's exactly what we wanted to have, no gas bubbles. And I have filled my Erlenmeyer flask, and we're ready to go on to number 3. Then it says to check out a lighter from your teacher. So I've checked out a lighter from myself, and I've actually put the lighter into my my trough. There you can see it floating or not floating over here on the side of the trough. I'm going to take it out in a minute, and I'm going to dry it and shake it out so that I can totally get any excess water out of it. So that's what I'm doing here. I'm just drying it off, and I am so I've gotten it wet. Now, why did I get it wet? Because on the inside of my lighter is a whole bunch of little spaces where I might have some water that catches and doesn't come back out again. And so that's why I got it wet to start with. And so the next step, it says to place the lighter on the balance pen and determine the mass to a nearest 0.1 gram. And so there is my balance. and I'm going to place it here. Please note that on my balance, I have already zeroed it to the 0 line here. So placing my balance or my lighter here, I can measure its mass. Let me see if it is under 10 grams. No, it is not. Okay, so let me see. 10 grams? Nope. About 20 grams? Okay, 20 grams is too much. So I'm going to place it back at 10, and I'm going to use the ones to record this. This is going to be an example of the first data that you need to record. And this is going to be under mass of the lighter before the experiment. So if we are talking about the data that you need to record, this is going to be the first data point, the mass of the lighter before the experiment. So let's go ahead and record that mass of the lighter before the experiment as 11.90. Mass of the lighter before the experiment is 11.90 grams. Okay, so then we're going to get ourselves back to the water trough, and by the directions, by the directions, it says that we are going to carefully hold the lighter underneath the mouth of the inverted flask, and we're going to lift it slightly and press and release the lever of the lighter, being sure that all of the gas bubbles enter the flask. So that is what I am going to do here with my lighter. I am going to get it underneath here, and I am going to, what I'm doing, and you probably can't see it very well, so let me move this way. All right, and I'm going to hold the lighter underneath here, and I'm going to release. You might be able to see some of the bubbles going into my Erlenmeyer flask. You can see there is a gas bubble that is beginning to form on the bottom here, and I basically have to hold this here until I fill the entire Erlenmeyer flask. Okay, you should have been so happy that we actually have did not record all of the time it took to get all of that gas in here. I have followed the directions and carefully held the lighter under the mouth of the inverted flask until I get approximately 200 milliliters of gas. And right now that line 200 milliliters is right here, and it's above the line of the water. And then it says, remove the lighter, dry it with a paper towel. So that's what I'm doing here, is I am drying the lighter with a paper towel. And so there is my lighter that we're going to have to shake to get all the water out of. Yes, I need to get all the water out of it. And I'll keep doing that. Set it aside for step 10. Then it says, do not remove the gas-filled flask from the water. Carefully raise or lower the flask until the level of water inside the flask is the same as the level of water outside the flask. And so what we're doing that for is, right now my level of water is at 200, and that's right now that's above the water of the inside of the flask. And I'm going to lower it down to where the 200 and the water on the outside of the flask are at the same level. And the reason why we want to do this is that we are equalizing the pressure on the inside of the flask and to the outside of the flask. And so we are going to record, going to be able to be at least a little confident that the pressure on the inside of the flask is the same as the pressure out here outside the flask. And that's why we're raising and lowering it. And then it says place the glass plate back underneath it. So I have it at the right level. I'm placing the glass plate back underneath it, and I'm bringing it out, and I am setting it back at my lab station. So there it all is, following those directions. Hold the plate in place, and I was careful not to spill any water. So we're on number 6. It says remove the glass plate from the flask, and with a graduated cylinder, measure the volume of water in the flask. And so here is my graduated cylinder, and I'm going to pour this volume of water in the flask. And I can report that this volume of water in the flask is actually, let me get my eyes down here, 59.5 milliliters. Okay, so where am I going to record that? I am going to record that at the volume of gas. The volume of gas, this was my volume of water used to, let me get it in the right spot, here was my volume of water used to fill the Erlenmeyer flask, and that value was 256 milliliters. The volume of water left in the Erlenmeyer flask was 59.5 milliliters. So if we are recording this value, again, this volume of water used to fill the Erlenmeyer flask, this one right here, that one there was 256. And this one here, that was the volume of water left in the Erlenmeyer, that was 59.5. When we subtract these and convert to liters, we're going to be able to find the liters of gas that we actually collected. Now, we also need to record our barometric pressure. So our barometric pressure for today, it is a bright sunny day while I'm doing this, our barometric pressure comes out to 758 millimeters of mercury. So record, please, 758 millimeters of mercury. Okay, so we're back to our directions here, and it says, remove the glass plate from the flask and with a graduated cylinder. We've done that. Record in our data table. We have done that. Then it says, determine the mass of the butane lighter you used and record that value. I am still going to need to get any more water out of it, so I am getting the water, finishing getting the water out of it, and we are going to take a look at the new mass of the butane lighter. Because we took some gas out of it, my butane lighter should be lighter. If it comes out heavier, that means I have not removed all the water yet, and I need to get all the water out. But I think I have here. So I've got this here, and it does look like it is not zeroed out. So I'm going to have to go and take out. Okay. So my new mass of my butane lighter is 11.40 grams. My previous mass was 11.90 grams, and my new mass of my butane lighter was mass of lighter after the experiment. That's 11.40 grams. And so you should be able to do the math there. Now, we are going to have to be able to find the vapor pressure of the water from a table. And that is because when we have a gas collected over water, we have to subtract the additional water vapor that might be entering that gas. And so we are going to do that part next by showing you a table of the water vapor. Okay, so what you see before you is a listing of water vapor pressures at different temperatures. And you know that temperature and pressure are directly related. So we need to be able to take a look at our how much pressure is attributed to the presence of water vapor in our collected gas. So that means we need to know the temperature of our water. And so currently what I have here is a thermometer in our trough, and I am taking the temperature right now, and it looks like it is, and the water vapor, there it is. So we are sitting at 22 degrees Celsius. So again, on your paper, recording your temperature means that you have to record your temperature of the water, which you need to convert to Kelvin, and the temperature of the water in Celsius is 22 degrees Celsius. So please make sure you've added 273 to report this in Kelvin. Okay, so let's go back to our water vapor graph so that we can see at a temperature of 22 degrees Celsius that we actually have a water vapor pressure. So here's 22 degrees Celsius, and here is our water vapor pressure of 254.6 millimeters of mercury. Okay, so that means that what we have in our flask, and I'm going to quickly draw ourselves a little picture of our flask. Here is our flask, and it's got the glass plate over the top of it. So in our flask, we have some water, which we have here, and we also have some gases, which are inside here. And the total gas pressure, gas total, as we've already said, was equal to the atmospheric pressure. And the atmospheric pressure we gave as 758 millimeters of mercury. That's the total gas pressure. But you have learned about Dalton's law, and Dalton's law said that the total gas pressure is equal to the summation of the partial pressures of the gases. So we have the butane gas, which is C4H10, and we have the water vapor, which is H2O. And we just found out that the water vapor pressure is 254.6 millimeters of mercury. And we were told the barometric pressure in this laboratory was 758 millimeters mercury. What you need to find for your data table is this partial pressure. So yes, you might already be able to see that, oh, I'm going to have to subtract. So let's go back to our, I'm going to erase that. Let's go back to our, make sure I can do this. There we go. Our data table. And on our data table, we are going to have to be able to, there it is, the converted or corrected gas pressure of butane. And so you are going to have to subtract the water vapor pressure out, just like we talked about. And of course, once you have it in millimeters mercury, you are going to have to record it in atmospheres. So when we're talking about the barometric pressure, this was 758 millimeters mercury, and the vapor pressure that we just got from the table was 200, and I have to look at it again because I've already forgotten it. Hang on, everybody. The vapor pressure from the table at 22 degrees Celsius was 254.6. So this one was 758, and this was 254.6. Yes, you will subtract these two, but then you're going to have to convert it into atmospheres. All right, so at this point, you should now have all the data that you need to be able to answer your questions. And the questions, as you can see, are to calculate the molecular weight of the butane. Then it says calculate the molar mass. This means from the periodic table. Then we're going to compare those with a percent error calculation, just as you see. The accepted value is your value that you just calculated as the molar mass. Then you have a couple of questions to answer about what if the gas collected was too high or too low, and then what can be done to reduce the errors. Once you have this all complete, then yes, you get to finish this out. You get to finish this out by turning it in. All right, thank you, everybody. Okay, so at the end of this laboratory, what you see here is the data that we have collected, and you have the appropriate conversions and pressures and temperatures and volumes and masses that still need to be worked with so that you can do the calculations. Please come to tutorials if there are any questions that you have, or catch me at the beginning of our next class.